What we're going to talk about now is a process called dimensional analysis. And really, this is something you're already used to. It's just a way to convert between different types of units. So you're more comfortable probably converting hours to minutes or hours to days. You do this frequently anyway. But what we want to talk about here is if I have different types of units like feet, inches, miles, how do I convert it to a different one? And also we want to talk about a different system that we don't typically use here in the US, except for in our science classes. So if you're anywhere outside of the US and you're on a highway or you're in a science class and you're taking some sort of measurements, you're not using the standard units we do. So our typical units of length are going to be feet and inches, where if you go to the UK, it's something completely different. Same thing when we talk about weight, we use pounds and ounces, things of that nature. And then when we talk about volume, then we use completely different stuff like cups, gallons, things of that nature. There's a more uniform system, though, that the rest of the world uses, and it's all really nice because it's all really in powers of 10. So we saw in scientific notation how if you have 10 to a power, all it does is move a decimal place. That's what this system is going to be based about. So more commonly used across the globe, the metric system is going to be used to talk about mass, length, and volume. And each of these three units is going to have some kind of base unit. So for mass, the base unit is going to be grams, which is going to be indicated with a G. For length, we have the meter, which is indicated with an M. And then for volume, we have the liter, which is indicated with an L. So the super nice thing about this is if you think of just our normal system, when you go through and have to convert from feet to inches, it's a really kind of strange measurement. So if you recall, 1 foot is going to be 12 inches. But then if I go feet to miles, there's 5,280 feet in 1 mile. So there's not this uniformity. However, with the metric system, what we're going to do to kind of talk about the size is we're going to put some kind of preliminary lettering in front of one of these base units. So in our chart, what I'm going to do is I'm going to start by filling out the center. Our base unit for weight is G, for length is M, and for volume is L. Okay, so this is kind of that standard unit for all of these. If I move to the left, this is going to give me a unit that is bigger. So in comparison to our system, you have feet. A bigger unit would be miles. So it's giving you a larger quantity. But now, if I go this way down the chart, it's going to give me something that's smaller. So if you think of feet as our standard unit, then inches would be a smaller one to get on a different scale. So what we do in front of these base units is we're going to put either 1 or 2 letters for our main type. So our biggest unit in front is going to be kilo. So all we do in front of that base unit is put a K. So we have kilograms, we have kilometers, and then for volume we have kiloliters. Then our second biggest unit is hecto. So we put an H in front of it. So hectograms, hectometers, hectoliters. Now the problem is we have 2 different D versions. We have deca and deci. Deci is the smaller. So we can't just put a D for one of these. So for our bigger unit, it's going to get the more letters. So deca, we put a DA in front. So we have decagrams, decameters, decaliters. Okay. Now moving to the smaller things, those are all the ones that end in I, centi, milli, deci. So that's how you know it's a smaller unit. So deci is going to just be a single D. So we've got decigrams, decimeters, deciliters. Centi is a C. So centigrams, centimeters, centiliters. And then finally for milli, we put an M. So milligrams, millimeters, milliliters. Okay. So the really, really, really nice thing is if I want to convert from one unit to the other, all I'm going to do is count how many spaces I move and what direction. So just to kind of give you an example before we do some real ones, if I want to go from kilograms to grams, that moves 1, 2, 3 spaces to the right, which means the decimal is going to move 3 places to the right. If I want to go instead from centiliters to hectoliters, that's going to move 1, 2, 3, 4 spaces left. So you move the decimal 4 spaces to the left. Because again, everything is based in tens, which is like scientific notation, so the decimal is just moving. So conversion within the metric system is really straightforward. So if you can remember essentially this top row of all of those letterings, you can easily convert back and forth. Now there are a couple different ways that you can go about remembering this. There's one that involves kittens, but I don't know that off the top of my head. So the way I remember the ordering of this is King Henry died by drinking chocolate milk. So this phrase tells you all of those starting letters. So King, kilo. Henry, hecto. Died gives you your first D, deca. By is going to be the base unit. Drinking, deci. Chocolate, centi. And milk, milli. So you can remember a different one if you want to, but this is kind of a standard one that's become a nice little phrase to help us out. So let's go ahead and utilize that now. Let's try some examples. We want to convert to the indicated quantity. So here I want to start with 2 kilometers and I want to convert to decimeters. So again, I could build this chart at the front, but I'm just going to run through my phrase and write down all of those symbols as needed. So to fill out my little chart, King Henry died by drinking chocolate milk. And so I don't want to put a B for by because that's our base unit. There's no letter that goes there. And so at this point, you could fill in this unit. For us, that base unit is meters. But you also really don't need to because the prefixes are all you need. The actual base unit is kind of insignificant here. And so we're starting with kilometers and I want to get to decimeters. So we count 1, 2, 3, 4 spaces to the right. So all that means I'm going to do is my decimal is currently sitting right after the 2. I'm going to move the decimal 4 spaces to the right. So 2 kilometers is the same thing as our decimal's currently here. We go 1, 2, 3, 4 spaces to move it here. And then just like with scientific notation, we fill in zeros in all of those holes. So 2 kilometers is the same thing as 20,000 decimeters. Okay. Same process for these next two. We've got milligrams and we want to convert to hectograms. So I'm going to start by going through my phrase. King Henry died by drinking chocolate milk. And here we are starting with milligrams and going to hectograms. And so that's 1, 2, 3, 4, 5 spaces to the left. So all I'm going to do is move my decimal 5 spaces to the left. So 4.2 milligrams, I got to move my decimal left, so I'm going to give some space on the left. It's got to move 1, 2, 3, 4, 5 spaces. And then in all of these blanks, we fill in zeros. So 4.2 milligrams is 0.000042 hectograms. Okay. Same exact thing for this last one. We're going to go from kiloliters to liters. So going through my phrase, King Henry died by drinking chocolate milk. And in this time, we're going to that base unit. So we are starting at the K and going to the middle of our chart. So we're moving that decimal 1, 2, 3 spaces right. So we've got 157 kiloliters. We're moving it to the right. So currently the decimal's here. We move it 1, 2, 3 spaces. And that means we're going to fill in 3 zeros. So 157 kiloliters is 157,000 liters. Okay. So within the metric system, the conversion is really nice. The problem, however, is when we start switching between the metric system and the US, or just within the US, or even when we're dealing with time, because time is standard across the globe. It's not so clear-cut or easy to convert back and forth between these things. So we're going to come up with another way that we can go about this. Now, realistically, if you're content doing this a different way, you absolutely can. So the method that I'm going to show you is really helpful when you have what's known as ratios. So that's when you have to do maybe multiple conversions, or you have like 2 quantities like miles per hour. So you might have to change one of those. This is going to be much more helpful for that process. So we're going to talk about this process known as conversion factors. So a conversion factor is a ratio used to change from one set of units to another through multiplication. So I'm going to work with one that we're used to. We know 1 minute is exactly the same thing as 60 seconds. So because these two quantities are identical to each other, what I'm going to do is I'm going to make a fraction involving both of them. So we have 2 conversion factors actually that pop out of this. We can put the 1 minute on the top and the 60 seconds on the bottom. Or we can do the 60 seconds in the numerator and the 1 minute in the bottom. Okay. Both of these, though, are really exactly the same thing. They're actually equal to 1. Although the numbers are different, they are the exact same quantity. And so if you think when you multiply by 1, it doesn't change anything. 5 times 1 is still 5. Negative 5 times 1 is still negative 5. So if I take an expression and I multiply it by either one of these two, it's not going to change the underlying meaning. And so that's how we're going to be able to utilize this to convert from one unit to the other. So what I'm going to do is I'm going to multiply 540 seconds by really both of these conversion factors. And we're going to see which one will convert it to minutes. Okay. So I'm going to kind of split this screen just in half right here to do so. So the goal is I want to get this seconds unit to minutes. And yes, again, I do not need to do this process. You can apply a different route if you're comfortable with it. This is just one that works in more complicated situations, and especially when we talk about volumes and areas as well. So I'm going to start with my 540 seconds. And I'm going to go ahead and multiply it by one of the conversion factors. The most common thing that people want to do is they have seconds. They want to put seconds in the numerator. So I'm going to start actually by multiplying by this conversion factor. So we're going to times this by 60 seconds over 1 minute. And remember, when you're multiplying a fraction, you kind of multiply the like pieces. So you can think of this as 540 seconds over 1. So you have a fraction times a fraction. And when you multiply two fractions, you just multiply straight across. So this is equal then to 540 times 60. And then if you think of the units, we've got to multiply them as well. So seconds times seconds is really going to give us seconds to the second power. And then in the denominator, you have 1 times 1, and then you have that single unit of minutes. And so what ends up actually happening here is you get a really funky unit in the end. Seconds squared over minute. I have honestly no idea what that unit represents. But all I know is when I multiplied by this conversion factor, it did not give me minutes as my final unit. So what I'm going to do actually instead is use the other conversion factor. So really, if you kind of look back up here, this is the most helpful tip. The seconds unit is sitting in the numerator. So if I want to cancel it out, I've got to divide by seconds. So I'm going to actually put it in the denominator. So we're going to take our 540 seconds, and instead I'm going to multiply by the conversion factor where I have seconds in the bottom and minutes in the top. And then I'm going to fill in my numbers. 1 minute is the same thing as 60 seconds. So by doing this, if you consider that 1 here, you have seconds divided by seconds. Those two units end up canceling each other out. And so all we're left with is 540 times 1 in the top. Then we have 1 times 60 in the bottom. And the only unit remaining is minutes, okay? And so all that's left now is to do the algebra. Really, you can kind of see at this point, if you have ones, you get to ignore them. Don't worry about them. So really all that's significant from these fractions is the 540 and the 60 in the bottom. So if you take 540 and divide it by 60, that's going to leave us with 9. So 540 seconds is exactly the same as 9 minutes. Okay? And again, you don't have to do this approach, but when you have complicated conversions that you have to do, this approach tends to work a little bit better. So we're going to continue with this. We're going to convert to the indicated quantity, and we're going to round to 1 decimal if needed. Okay. So what you see here is we've got a chart that gives us a lot of the conversion factors. You're expected to kind of know the basic ones like with time, but for our class, you don't need to know that there's 5,280 feet in a single mile or how many yards are in a mile. Perfectly okay. That stuff will pop up there for you. Same thing like how many inches are in a centimeter. You're not expected to know those numbers off the top of your head. The more complicated stuff will be given to you. So what I want to do in this one is I want to convert my miles unit to inches. And I'm going to use all the information in this chart. The problem is I don't have a direct conversion from miles to inches. However, I can go from miles to feet. And then I know how many feet or how many inches are in a foot. So what I'm going to have to do is 2 different conversions to get to the one that I want. So I'm going to start with my 2 miles. And what I want to do is I want to multiply by something that gets rid of my miles unit. So that means I want to put miles in the denominator. So this way those two cancel each other out. And then going to my chart, this one down here is how I can get rid of miles easily. So I'm going to fill in my pieces. I can convert from miles to feet. 1 mile is 5,280 feet. Now this again does not get me to the inches unit that I need. So I'm going to have to go ahead and do it again. And because I have feet in the numerator, I want to put feet in the denominator to make that unit disappear. And then from our chart, we know that 1 foot is equivalent to 12 inches. So this is going to put my inches unit in the top. and then filling in my numbers, 1 foot is 12 inches. So the only unit that's remaining now is exactly what I want, inches. So all we're left to do is all the multiplication. You look at all the stuff that's in the numerator, all the stuff that's in the denominator, and thankfully here, the only thing that's in the denominator is dividing by ones. So I really get to ignore them because we're gonna do 2 times 5,280 times 12 divided by 1 does nothing. And then our unit left over is inches. So if you go ahead and multiply all these out, 2 miles is equivalent to 126,720 inches. Okay. Now let's try this next one. We're gonna have to convert 80 miles per hour to feet per minute. So we've got 2 conversions that have to go on here because we have miles per hour. Miles has to change to feet and hours has to change to inches. So if you think of this quantity, we're going to talk about rates a little bit later on, but miles per hour is telling you that you're going 80 miles every hour that you drive, okay? So we can write this as a fraction. 80 miles per hour is 80 miles divided by 1 hour. So I'm going to have to do 2 conversions, and I'm going to start with the miles unit. And so I want to change miles to feet. And since miles is in the numerator, we're going to go ahead and put it in the denominator. And then we can put feet in the top because this will make that miles unit cancel. And then using my chart, 1 mile is 5,280 feet. So we're good. We've got the feet part down. Now I want to get per minute. And here's where using this is really helpful because currently the hours unit is sitting in the denominator. So if I want to cancel it out, I'm going to have to put it in the opposite spot, which is up here in the numerator. So I want to put my hours unit in the top and then my minute unit in the bottom, okay? Because what's left over then is feet per minute, because that per means in the bottom. And then filling this in to make it an equivalent statement, 1 hour is equal to 60 minutes. And so you can see we'll worry about all this subtraction and stuff at the end. What's left as the unit in the top is feet, and in the bottom, it's minutes. So filling in our important numbers, we have 80 and 5,280. And in the bottom, we have 60. So we've got to multiply the top, then divide by 60. And this tells us that 80 miles per hour is the same thing as 7,040 feet per minute. So you can write it out. You can write feet per minute, or you can use that fraction like this, either one. Okay. So the very last thing we're going to talk about is if we're working with area or volume conversions, you have to be careful because in some instances you'll be given a direct conversion because maybe they'll tell you that 1 foot squared is 144 inches squared. That might be given to you. However, what might instead be given to you is just a single conversion, that 1 foot is equal to 12 inches. So depending on the problem, you might have to do multiple conversions because feet squared, remember, is feet times feet. If you have volume, it's the unit cubed, that's centimeters times centimeters times centimeters. So if you're given the conversion like this, you're gonna need to do 2 conversions for area. And for volume, you'll have to get rid of all 3 of these, so you need to do 3 conversions. So again, it does depend on the problem because if you're lucky and given this first case of a direct area conversion, you're golden. You don't have to do too much work. But if you're given just that one-dimensional conversion, you've got to do more. So we're going to try that case. We're going to convert each of these quantities and we're going to round to the nearest whole number if we need to. So we're going to start with 1,000 centimeters cubed and we're going to convert it to inches cubed. So you can see here, we're given that one-dimensional conversion. We're not told how many inches cubed is how many centimeters cubed. So what I'm going to have to do here, I'm starting out with 1,000 centimeters cubed. That's the same thing as 1,000 centimeters times centimeters times centimeters. So I've got to get rid of each of these centimeters units. That means I'm going to have to multiply by 3 conversion factors. And in each instance, centimeters is going to go on the bottom. So this way, the first fraction will cancel the first centimeters. The second cancels the second. And the third cancels the third. Okay. And in that case, then we're left with inches, inches, inches on the top, which is inches to the third. So filling in our pieces, 1 inch is 2.54 centimeters. So every single one of these is at least going to be the same conversion factor. And so what we're left with in the top is 1,000. All the ones do nothing. In the bottom, we'll have 2.54 times 2.54 times 2.54. And then that unit, again, inches times inches times inches is going to give us inches to the third. Okay. So be careful when you plug this into your calculator, especially if you're using your phone. You're going to have to do some parentheses. You should get that this is about equal to 61 inches cubed when you round to the nearest whole number. Okay. Let's do one more. We're going to convert from feet squared to inches squared. And again, we are given a single dimensional unit. 1 feet is equal to 12 inches squared. So over here, we're starting with 196 feet squared, which is really 196 feet times feet. So we've got to multiply by 2 conversion factors to get rid of both of the feet. And they will go in the denominator with inches in the top. So this way, the first one cancels and the second one cancels. And then using our numbers, 1 foot is 12 inches, 1 foot is 12 inches. And so what we're left with is we need to do 196 times 12 times 12. And then our inches times inches gives us inches squared. So going through, multiplying the two, this tells us that 196 feet squared is equivalent to 28,224 inches squared. Okay. And to just kind of show you the other approach too, I'm going to go ahead and just do this off to the side right here. What you can do is you can actually kind of manipulate this a little bit. So at this stage, if you know 1 feet is 12 inches, go ahead and square both sides. So 1 squared is 1. So 1 foot squared. And then 12 squared is 144. And then you're left with inches squared. So same thing up here, you could have said that 1 inch cubed is the same thing as 2.54 cubed centimeters cubed. Just go ahead and multiply everything out. Because now you have this conversion factor for the area. So it saves you just a tiny bit of time because 196 feet squared. Now using the conversion factor, we put feet squared in the bottom, inches squared on the top. And 1 foot squared is 144 inches squared. And so if you take 196 and times it by 144, the unit remaining is inches squared. And you still end up with exactly the same thing. Okay. So completely up to you which process you could do. Again, you can just do multiply by however many conversion factors you need to get rid of the unit, or you can go ahead and make that area or volume conversion from the one-dimensional one that's given to you. And again, if you want to find a different approach, there's tons of other stuff online you can look up. Whatever really works for you, if you're comfortable with it, go ahead. There's a lot of ways to do these kinds of problems.